Welcome to Embedded System Lab 2 demonstration. Okay, in the last class we have discussed LED blinking exercise in the hardware demonstration. Today we plan to conduct the second experiment, that is interfacing of switch with Arduino. We hope you people very much clear in the particular experiment, because already we have finished the simulation on the same. We are going to continue the today's task from the last simulation lab experiment. That is, now we are going to refresh what we have discussed in the lab class with the help of the Tinkercad software. Okay, first we are going to open the Tinkercad link. Okay, using my credential I am opening the Tinkercad account. Okay, in that already we have a second experiment, that is interfacing of switch with Arduino. Where it is? Yes, here. Go to circuits. Yes, here we will find the experiment number 2, interfacing of switch with Arduino. What we are going to do? We are going to use the same simulation setup for our refresh our experiments procedure. Okay, you skip the meters whatever connected there. Okay, the simple thing, we are going to check how we have interfaced the switch and how we are going to produce the output according to our switch status. Okay, so let me start simulation once. And we will check the output. Okay, here our switch is connected in the pin number 10 and the LED is connected in the pin number 12. Okay, now my push button switch is in released condition. Okay, whenever I press the push button, it makes the output LED to turn on. Please observe. Now the LED is initially in off state. If I press the push button, LED is getting turns on. Okay, but in our hardware setup, we are not going to use the push button. Instead of that, we are going to use some dip switches. So what we will do? We will stop the simulation and replace this push button with the dip switch. Where the dip switch is available, I need to change this menu into all, then only we will see the dip switch in our simulation software. Yes, we will take this dip switch. Okay, yes. So what is the connection procedure? Actually this is our output terminal, this is our input terminal in our push button connection. Am I correct? So what we will do, we will take this 1A and 1B, this terminals for particular experiment. So let me move little. So now 1B is connected with the output terminal. Okay, what else I need to modify? Only the input terminal 1A. How to modify? Very simple. We will change this input wire alone to 1A. That's all. Hardware connection is over. Please check it. Now we are going to start the simulation again. Initially my LED is in off state. Now let me change the dip switch position to on. Yes, now the LED is on. Now let me change the dip switch position once again to off. Please observe the LED status. Now bringing back the switch to the initial position, that is off. Yes, LED is off. That's all. The same thing we are going to demonstrate with the help of the hardware setup. So how to start? Is it we need to write the coding once again? No need. Please go this option, export option, then click. There you will find, yes, Now actually we have simulated our work. We need to dump the same thing, that is the code what we have written. We need to upload it in our target hardware. Okay, the target hardware is nothing but our Arduino Uno board. So what to do? Whether we need to type the coding once again? No need. Go to this option, code, click this. There you will find an option called the download code. Simply click the code. Please click the icon, download code. Yes, now what happened? The particular code was getting downloading. We are unable to view that. Let me show. Go to download option. Go to download option. Can you see this? Can you see this icon? This folder starting with the end with the .ino. Let me little change this icon pattern. Can you see this? So this is our Arduino code file. Simply double click over this. Already we have installed Arduino IDE in our laptop. Thereby we are unable to open that particular code immediately with the Arduino IDE software. If not, what we have to do? First time you need to install the software in your laptop, then only you can access that .ino file created by the Tinkercad. Actually, this is a general extension. Whenever you do project with the Arduino IDE software, you may notice the software what we have written using the Arduino, it will save with the same extension called .ino extension. Okay, so whenever we open this kind of this coding immediately, by default our Arduino IDE will create one folder with the same name. Okay, so Arduino IDE will create the one folder with the same name. Can you read this? Can you read this pop-up message? The file experiment number 2, interfacing of switch with Arduino 1.ino needs to inside a sketch folder name, the same name it recommends. Okay, so what we need to do? We need to create the folder, move this file and continue. Simply click OK and observe what is happening here. See, can you see here? It's created one folder and moved. See, let me open this. Can you see? So whatever we have downloaded, now it's automatically moved into the one folder. Then it pop up the coding what we have written. Please observe whatever we have written in the Tinkercad. Now it is available in our personal computer. Now what is the next task? We need to connect our external hardware, then we need to upload this code into our external hardware. That part already we have discussed in our first exercise. What we need to do? Very first thing, we need to click our verify icon to compile the code, to check if there is any error in our code. Let me click the verify icon and also observe the status menu update. See, please observe compiling sketch. Once it's successfully compiled, you will get the message as done compile. We will wait for that. Now the compiling action takes place. We will wait for a moment to change the status value into the compiled. So it is taking time. So you can observe this process bar, the green status. Once it's completed, here you will get a final command. Okay, we'll wait for some time to get compiled. Now it is compiling sketch. So the status need to update into done compile. Once it converted successfully, then our code is ready to dump into our external hardware. Okay, it is taking little time. Please wait. Yes, now you observe done compiling. That means what? Now we have successfully compiled our code, you can see the size of the code, it is 898 bytes. So we have used 2% of our program memory. What is the maximum size? It is 32 KB. Okay, so these messages, whenever you do compiling action, please go through it. How much percentage of memory you have used. So that's all from the stage 1. Stage 1, what we have did, we downloaded the code from the Tinkercad and we compiled the code using Arduino IDE software present in the laptop. The second part, we are going to see the hardware demonstration. In that, we need to upload the code into our target hardware as we did in the first exercise. Yes. So far we have finished compile action. So our software coding is ready to upload in this our Arduino Uno board. Okay, so this is the Arduino Uno board, you know well. Then this is the USB cable to transfer our program from personal computer to your target hardware. Okay, then where is the switch and LED? So we don't have any discrete component. Here we have our IO board. So this is our switches. So same dip switch we have used in our hardware also. Okay, then we are going to use any one of the LED to make the output. Okay, so very simple. We are going to take any one output. So here you won't find two terminals in the dip switch. You will find only the output terminal. So from the output terminal of the switch, we need to connect it to the port number 10 in our Arduino hardware. Okay, then from the pin number 12 in the hardware, we need to connect it in the LED. I hope you remember the connection what we have established in our Tinkercad software. So now we will make, before making the hardware connection, very first step, we will upload the code into the Arduino board. So as usual, connect your USB cable in this USB port, then the other end of the USB cable connect it in your computer where we have written our coding. Okay, so we are going to plug the USB cable in the personal computer, okay, or the laptop. Then please observe, the moment you connect, you can observe the power on LED. And why this 13th LED is blinking? I hope you remember in our first exercise we did blinking and LED exercise. The same coding is present still in the chip, therefore it makes the 13 LED to blink. Don't bother about that. We will start upload our new coding. How to upload? Please concentrate in our Arduino IDE. Go to the second icon. Before that, go to tools and ensure whether we have chosen Arduino Uno board. Yes, it is selected. So how to select? Let me show once again. Go to this board option, then go to Arduino AVR board option. In that we need to choose Arduino Uno. Okay, then again go to tools. And we need to select the port. Here at present you can view our board is connected in COM40. Okay, 40. Therefore I are going to select the COM40. That's all. Now successfully we have selected the COM port. The next option is what? Yes, very good. We need to upload the code. So click the upload icon and also observe the transmit and receive LED in our Arduino board. Now we are going to click the upload icon and parallelly please observe this RxTX LED. Okay, yes. Now we are going to click the upload icon and also you can observe the status in the bar. See, it's getting uploading now. Have you observed the RxTX LED blinking status? Let me upload it once again. I am clicking again once again. Please observe the LED status in the RxTX LED. It indicates there is some yes, the movement. Yes, now it's you can observe the LED blinking of RxTX. That means the code is successfully uploaded. Okay, please check the status bar in our IDE. Here it is done uploading. That means successfully we have uploaded. Yes, now we will come to the hardware portion. So what is the precaution? Before start giving the hardware connection, we need to disconnect the power. So we remove the USB cable. Thereby there is no power in the Arduino board. Now we will start give the hardware connection. You can remember how we start giving the simulation hardware connection. First of all, what we will do? We will power our IO board. In our simulation, we will power our breadboard. Okay, here we need to power our IO board. Here you can find 5 volt and ground. These two are power pins. From where we will get the 5 volt? From where we will get the 5 volt? Here you observe. You know Arduino power pins. From the power pin 5 volt and ground, we can power our IO board. Okay, first what we are going to do? We are going to connect 5 volt. We are going to connect the 5 volt in the Arduino board. Then the same 5 volt we are going to connect it in our IO board 5 volt. Thereby VCC is connected from our target board to the IO board. What is the next connection? What is the next connection? We need to connect the ground. So that is our zero potential, ground. So ground from the Arduino board to, we are going to connect it to our IO board. That's all. Thereby successfully we have made the VCC and ground connection. What else remaining? Only two things. That is, we need to connect the output terminal of the dip switch to the port pin number 10. Port pin number 10 in our Arduino IDE. Yes, that's all. We have connected the switch connection. What else remaining? Only one hardware connection is remaining. That is, we need to connect this LED terminal to any one LED we will take, that we need to connect it in port number 12. That's all. Hardware connection is over. Please observe what are the connections we made. First we have connected VCC and ground to the IO board. Then from the switch we have connected in pin number 10. Then from the 12 we have connected one LED. That's all. Now the code is readily available. The moment we give the power to the board, so we are using same laptop USB port to power our Arduino. Please observe. Now the dip switch is in off condition, thereby our LED is also off. Now we are going to make the dip switch to on. Okay, please observe. We are making dip switch to on. The moment if you make the switch to on, the LED is turned on. That's all. Is it the whole thing is verified? No. What do you have to do? Again change the dip switch position and ensure the LED status. Again we are going to adjust the dip switch to off position and observe the LED status. It is off. That's all. Thereby our second exercise, interfacing of switch with Arduino. It is not only switch. We need to observe the function of the switch. Additionally, we need to add one more LED. That's all. Thank you.